and Learning Center. Welcome to our webinar on implementing the Common Core State Standards mathematical practices using Singapore math strategies and problem-solving structures. Well, hello everybody. We are so pleased to have such a large crowd today to learn more about the Common Core State Standards math practices, and I'm particularly to introduce two colleagues, both of whom's reputations are literally worldwide. I'll get to them in just about a moment, but I want to first welcome everybody to our webinar, and for those of you who have not joined us in the past, say a few words about what's coming up at the Leadership and Learning Center. We'll be having our National Math Summer Institute in beautiful Colorado, and two of the speakers that you'll hear today will be participating in that, along with Dr. Richard Bisk, Dr. Richard Allen, Tremaine Nelson, and Jan Christensen, who you may recognize as the co-author of 5 Easy Steps to a Balanced Math Program. I'll say more about Dr. Yeap Ban Har and Rachel Syrja in just a moment. During our 3-day National Math Summer Institute, you can see how Singapore math instruction is accessible and effective with all students, explore the structures to create balance within the math classroom, providing success for every student, and engage in live grade-level math demonstrations. We've also added some new and updated resources that you see before you, both the publications as well as the conferences and events. We'd welcome your inquiries about those. We also have added new Common Core navigation aids, and I think that's exactly the right word. People are telling us across the country that it's the implementation of the Common Core that they need most help with. They know what the content is. This will help you navigate the assessment and collaboration processes with the Common Core State Standard. I'm going to introduce my first guest, Dr. Yeap Ban Har, who taught at the National Institute of Education for the last 10 years before taking up his present 2 positions as the principal of Marshall Cavendish Institute, a global professional development institute, and the director of curriculum and professional development at Pathlight School, an autism-oriented school. He teaches courses at National Institute of Education, the SEED Institute, Wheelock College, Rajapat Manhasa, Rakham University, and has written several mathematics textbooks based on the Singapore mathematics approach. I can tell you that when Dr. Yeap Ban Har was with us last summer, it was a standing room only group. Welcome, Dr. Yeap. We are so honored to have you with us today.
Thank you.
Also joining us is Rachel Syrja, Professional Development Associate with the Leadership and Learning Center. During her almost 20 years in education, she's been a classroom teacher, mathematics coach, and resource teacher, and a professional developer. She's the author of the brand new How to Reach and Teach English Language Learners and the soon-to-be published Common Formative Assessments for English Language Learners. Everywhere Rachel goes, particularly when she reaches the needs of English language learners, she makes a profound difference for students. Rachel, welcome to our discussion.
Thank you. Good morning.
Rachel, are you there?
I am.
Okay.
Good morning.
So I'd like to let Dr. Yeap Ban Har start and let us hear about the learning approach described colloquially as Singapore math.
Actually, I always start by saying that there is no such thing as Singapore math. Singapore math is really just mathematics taught based on learning theories that has been around since the 1960s. It so happened that we tried it out here for many years, and we have seen the achievement of the students improve over the years. So if people ask me to tell them one thing about Singapore math, it is always this CPA approach, where students are introduced to any concept through the use of concrete materials, and afterwards they move on to pictorial representation before they go on to learn the abstract symbolism. So the CPA approach would be fundamental to Singapore math. Here is just an example. It has now becoming quite famous around the world, and we call that the bar model. So the bar model is an example of a strategy that is prevalent in our classrooms because it's prevalent in our textbooks. So if you see the example on the screen, this is one use of the bar model for children to learn how to figure out how to solve a problem such as the one that's on the screen. So bar model is a method where students use a bar to represent a quantity. In this case, it's an unknown quantity, which is Jake's savings. And in particular, in this case, it is used to help children figure out something that is traditionally quite difficult, which is fractions. And I leave you to see how the bar model helps students see 1/4 of Jake's savings being spent on the gift, and then 1/6 of the remainder. And it is kind of clear to 4th graders, 5th graders, that the $55 is actually that 5 little units. And from there, children can just figure out on their own already. The bar model is something that our Department of Education created because our children were having such a great difficulty with word problems, in particular those that involve ratio, fractions, and such. So this is a little bit of Singapore math, I would say. Something else that is about Singapore math is that we teach a few related ideas over a rather long period of time so that students have really ample opportunity to master a concept. So it is almost never that you see during one lesson the teacher would jump from topic to topic. So the teacher will not only spend the entire lesson, for us it's about an hour, the entire lesson on one concept, in fact over 5 days, a week, sometimes a week and a half, 2 weeks, the students are going to be dealing with just a few related ideas. For example, in 3rd grade, they could be doing equivalent fraction, and then the following week they could be doing addition of fraction that require equivalent fraction. It's always a few things over an extended period of time. And Singapore mathematics curriculum focuses on things which are really critical. So we de-emphasize 3 things. We de-emphasize computation, as in tedious computation. We encourage mental computation. We de-emphasize procedure, but instead emphasize on conceptual understanding. And we de-emphasize memorization. So in fact, there is this statement from our Ministry of Education, the Department of Education, that says that mathematics is really just a vehicle. In fact, the quote says it's an excellent vehicle to help children develop and improve their intellectual competencies. So our mathematics program, in tandem with all other subjects, focuses on preparing students for the future, as in using mathematics to sharpen their ability to visualize, their ability to see connections, their number sense, essentially all the human qualities. And this being quite a different way of teaching mathematics, different from the way we were taught when we were children ourselves, because we only implement this way of teaching since 1992 to the 1st grader. Professional development become kind of critical because we need to help our teachers understand what is it that they are teaching on a daily basis. So PD is really a big thing in Singapore today.
So we're going to stop at this point and ask for some interaction from our audience. And you'll see, don't answer these yet. You'll get a poll where you can select one or more than one answer if you prefer. So I'm interested, Dr. Yeap Ban Har, tell us about your inferences from what our clients are saying here.
I think this is quite typical around the world. Teachers always like to learn more strategies, but they also appreciate that they may need some help with the content and the way of delivering the content. So I think what we see here is quite similar in trend to almost everywhere else where I have asked this question.
I'm actually very gratified to see how low something that motivates me score. That would imply to me that maybe we're over the hump, that people accept that these are skills that every student needs to be a citizen in the 21st century. We're not asking them all to have math and statistics degrees, but we are asking them to know enough math to confront the practical challenges that they face every day as citizens and consumers. So it sounds like the motivation is there. Now we just need the strategies. So let's proceed. And Kathy, you'll have to shut off the sharing polling results.
And this leads beautifully into the 5 easy steps for the balanced math program. And actually just a few clarifying points.
Rachel, this is Kathy.
Yes.
Before we start that, we have a question, Doug. Before we move on, I apologize, and a couple of people have asked if you can repeat the 3 areas of focus for Singapore math.
So
Pardon me, Katie, can you repeat the last bit that you said? I couldn't hear it.
Oh, I'm sorry.
People are asking you to repeat the 3 areas of focus.
Right. So the 3 are just the ones which are the most important one. The 3 focus that we described earlier is the focus on concrete representation prior to pictorial representation before learning the abstract symbolism. So in brief, in Singapore, we call this the CPA approach, concrete, pictorial, abstract approach. Also emphasizing on things that matter, in particular, thinking and problem solving instead of mere computation and memorization and following procedure. And the third feature, which is related to the previous, is the emphasis on the use of bar model, which is a visual strategy. So those are the 3 features that I brought up, which will be, you would say, those are the key features of the Singapore mathematics curriculum.
Thank you. So Rachel, tell us about the 5 steps to the balanced math.
Okay, thank you, Dr. Reeves. So about the 5 steps to a balanced math program, just a point of clarification. The 5 easy steps is not a math program. It is a way of structuring your math program, structuring what you're currently doing in math. And the beauty of that is it can be applied to any math program that is currently in use in a district. I've worked with several districts across the country, and with every program from a traditional math textbook to everyday math to Singapore math, many different math programs. And so as we go through, and my focus will be specifically on problem solving within the 5 easy steps. However, I will address each of the 5 steps just generally for you right now so that you have a general idea of what those 5 components are that make up the 5 easy steps. So let's just assume that you have a current math program, a current math adoption, or you're in the process of adopting a math program. What the 5 easy steps does is it helps you to organize and systematically set up your math program in a way that helps students to make sense of math. And it was born out of, the program was born out of that same frustration that Dr. Ban Har was speaking of when he mentioned that students in Singapore really lacked the ability to problem solve. That's a problem that we also face here in the United States. We have students who lack the vocabulary, who lack the language, and who frankly just lack the mathematical background to be able to tackle problem solving. So in an effort to try to tackle that, Jan Christensen and Larry Ainsworth developed the 5 easy steps within their own classroom. So it was something that was developed by teachers, by practitioners, as a way of addressing the fact that they had so many students who were coming to them lacking that ability to have number sense, lacking the ability to problem solve. They really did not have conceptual understanding. They had a huge issue with students who came into them without knowing their basic math facts. And then, of course, the whole idea of here's where our students are now, where do we take them from here, which basically makes up those 5 steps of the 5 easy steps program. So it starts with that step 1, which focuses on repeated reasoning, which you'll also see when we get to the next slide, which will, is part of the math practices. You'll see that listed there. But if we could go back again, Dr. Reeves, we'll just spend another second on that previous slide. So step 1 really covers that idea of if students come in lacking certain concepts and ideas from the previous grade level, how can we make sure that through a daily math review and mental math practice, we can get students to fill some of those major areas of understanding that they need to be successful in the current year. And just another point of clarification with step 1, it is more than just a morning math sponge or a daily warm-up. It is very, very deliberate, very structured, and it is structured for understanding, for number sense, for teaching number sense, and it provides students with that understanding, again, that they need in order to be successful with whatever they are currently learning in their math program. So the question that we always work with teachers on setting up step 1, the question that we have them ask themselves is, what is it that students are lacking that's keeping them from being successful on what I'm currently teaching them? So what are my students lacking? I'm about to teach this unit in mathematics, but they're lacking some key understandings that are going to prevent them from being successful. Once I have those ideas, and we've collaboratively with my PLC, with my data team, we've decided on what those topics are, we set those up as our daily math review, and also we expand on those through the mental math practice. Step 2 is the problem solving, which I will elaborate much more throughout the course of the remainder of the webinar, but is basically the pulling together of what we are currently learning. It's the application of what we're learning. So what we do very deliberately through the 5 easy steps is we ask teachers to take a look at what they're currently teaching and then to seek and to develop problem-solving experiences that are the application of that mathematics. And again, what we want students to see and what we want students to have is an understanding that math is not doing numbers 1 through 30 odd. And I think that what we see is that our students have this understanding, this very clear misunderstanding of what the application of math is. They think of math as a problem set, and so through problem solving, we want students to make that connection that what the math that they've been learning has an application to the real world. And so we make that transition and we set them up for success with some very structured processes that will help them experience success in problem solving. Step 3, conceptual understanding, is basically the way that you set up your unit of instruction. And again, because this program works with any math textbook, we are basically just organizing the learning for understanding, again, so that our students leave that unit of instruction with the understanding that we want them to have. And then step 4, mastery of math facts, is something that we work on with basically our K-4 teachers. We go into schools, and in these schools that have 5 easy steps, we work on developing a very well-defined math fact program that is not about drill and kill. It's about understanding the mathematics behind the math facts. And it's about teaching them fluency and having them be very fluent with their ability to deconstruct numbers, to pull them apart, and then to reconstruct them, pull them back together again. So again, it's all based on number sense, not on drill and kill. And as a matter of fact, one of the things that we really de-emphasize through our Mastery of Math Fact program is a heavy reliance on mad minutes or timed tests for teaching math facts. And again, just to clarify, we de-emphasize those processes as a way of teaching the math facts. We can use mad minutes, we can use those types of tools once students have fluency with numbers, once students understand the math behind those math facts, and once they've developed the strategies that are more effective than, let's say, for example, them counting on their fingers or using their fingers when they're doing math facts. And what we see is when we move too quickly to timing students, it makes them fall back on, or it causes them to default to that, to what's comfortable to them and the strategy that is most effective for them at that point, which in most cases happens to be the use of their fingers to try to solve a simple addition or subtraction problem. And so Rachel, we really,
we're going to have to move on. Before we do so, let me ask Kathy, we have another question from our audience.
Absolutely. We do, actually, and this is for Rachel. The 5 steps make sense, but how can we get the below grade level math students caught up?
Well, that's a great question, and it's exactly why step 1 is there. That whole idea of making up for or trying to close the gap between where students are and where they need to be. And what makes it so effective is we don't look at everything that they possibly are lacking, that they're lacking in terms of understanding, but we take it one unit at a time and one concept at a time. So we ask ourselves at the beginning of each unit, what is it that they are lacking for this specific concept that we're about to teach? And in that way, we don't overwhelm ourselves and we don't overwhelm our students in trying to close, because we know that some students have some tremendous gaps. So when we look at those 5 steps, the last two, or the last one was the common formative assessment piece. We look at the Common Core standards for mathematical practice. What we know from the standards document is that these mathematical practice standards should not be an afterthought, but should be something that is tied into the teaching of mathematics on a daily basis and something that students should have experience with regularly. And so one of the things that we know just from looking at them and from the description that I just provided for you of the 5 easy steps, we can see that through the 5 easy steps and also through what Dr. Ban Har shared with us, these 8 practices are covered beautifully through those 5 easy steps to a balanced math program.
Okay, and quickly, are these also used for the secondary high school levels as well?
Yes. Yes, the 5 Easy Steps math program is a K-12 math program. We implement it in high schools across the country. We've implemented it in elementary, also in middle schools. So it is a K-12 program. Thank you.
So it's time for our next poll question.
Okay, so what we are looking for here is we want just to get a little bit of background on you and a little bit of insight into your understanding. What are the best ways to develop the capacity to problem solve?
Take about 30, please, and then we'll display the poll results.
Okay, so a lot of you looked at D, the teaching of key strategies, with B being the next highest response experience with success in problem solving. In all actuality, B is the correct answer. The teaching of key strategies is a part of teaching of students having success with problem solving, but what we want to be very cautious with is the idea that there is one strategy for every type of problem, or for a specific type of problem, there's a specific strategy that goes with it. We don't want students to walk away with that idea, and a lot of times when we focus on the teaching of key strategies, or even selection A, the teaching of key words, or the teaching of signal words, what we often end up doing inadvertently is teaching kids that there is this formula and that you search for some keywords, and then those keywords lead you to a specific strategy, and then that will lead you to success. Oftentimes what's found on state tests, the problems don't contain keywords, or they don't contain those signal words, and so students find themselves lost and find themselves very confused and unable to tackle those problems. So what we know from research is that students need to experience success with problem solving, and they need to experience repeated success. And through that building of success, that's what not just continues their interest in problem solving, but keeps them motivated and keeps them going. So when we do something and we're successful at it, it keeps us wanting to come back and wanting to try it again. And what happens in so many of our classrooms is students are not experiencing success. And so because of that, as soon as they see a word problem of any sort, they tend to check out. They tend to think that I'm not going to be able to solve it, so why should I even try? And so there's that lack of perseverance, which we know through the standards of mathematical practice is a very, very important piece. We need to teach kids to persevere. And the whole idea behind that is that we give them the tools to be able to persevere. And that's what we'll see in the 5 easy steps, in the problem-solving component of the 5 easy steps to a balanced math program.
So
Dr. Reeves,
let's close the poll results because we've got a lot of material to cover here in the next few minutes.
Right. So if we could go ahead and go back to the PowerPoint. So the rationale behind, there's a writing component to the 5 Easy Steps problem-solving piece of the program, and basically the rationale behind the writing piece is that we need students to communicate their thinking, not just to their peers, but to their teachers, to others, and then we need them to analyze and evaluate their thinking and the strategies that they've used. And all of this needs to be done through the use of mathematical language, and we know that that final bullet, the use of the language of mathematics, is a critical piece. It's something that we know students struggle with immensely in classrooms across the country. And then we have this quote from Marilyn Burns that again reinforces the importance of writing in a math class and how it provides a window into their understanding and provides a lot of information for us. So if we're looking for ways to differentiate instruction, ways to provide those next steps of learning for our students, the best way to do that is to have students write, because when they write, we can see what their misunderstandings are in terms of their math learning and their math thinking. And what we know about children's natural ability is that they come to us with already this intense curiosity, and they're problem solvers naturally. And what happens is through the course of the way that we set up our teaching of mathematics, and particularly our teaching of problem solving, oftentimes that natural ability is squelched and not encouraged. So we want to make sure that students know that they can persevere. Through perseverance, they can take that natural ability and apply it in many different situations. So there's a few critical steps to problem solving that we reinforce in this component of the 5 Easy Steps, the first of which is defining the problem, making sure that students can read through the text of a problem and really understand what it means. Then they are taught to select the relevant information from that problem. They're taught to represent the information, and then they plan and modify a process to be able to solve the problem, and once they've gone through their solution, they can come back and verify that that strategy works and that perhaps it can even be applied in a different setting. So when we go through and work with schools on problem solving, we teach them how to very, very deliberately select problem solving tasks. And one of the first questions that we ask is, does this problem solving task relate to the current unit of focus? So is it, again, the application of the math learning that we are currently that we're currently learning about? And then is the problem accessible to all my students? So given the structures that we provide in the 5 Easy Steps, we basically set kids up so that they're able to be successful. So it's a very scaffolded process in the beginning that is gradually released to them as they become more successful. So what we want to do is we want to make sure that the problems that we select are accessible to them, that they're able to experience success given the structure that we've provided for them. Does it challenge their current math understanding? And again, when we want to challenge students, we don't want them to feel success with something that's very easy or something that they know isn't challenging, because that doesn't really motivate them. But when they know this is something that's a little challenging to me, it's something that I really am on the verge of understanding, then that provides that motivation that we're looking for. And then does it involve ideas from more than one mathematical strand? Can it be applied to several different mathematical strands? And then the final question, probably the most important of all, is do I understand the math problem, the math in the problem? And we encourage our teachers not just to answer that question, but to actually solve the problem themselves and try to solve it in multiple different ways, so that we can anticipate the ways that our students will be solving the problem, and so we can try to encourage or to help them when they get stuck in one of those particular solutions if they chose a different approach.
This is Doug. I might just add parenthetically that when we, in our professional development approach to developing standards-based performance assessments, one of the steps that's not always very popular is that people actually have to solve the problem that they created themselves and have their colleagues do the same. Because when a fourth grader doesn't understand the directions, as we all know, it must be the fourth grader's fault. But if a colleague with a master's degree gets a wrong answer and doesn't understand the, and having just made a mistake on second grade homework last week, I can tell you, it's been known to happen, then it will maybe make us step back and clarify the problem. Kathy, before we move on, any more questions from our participants?
Yes, we do. One is, in dealing with fluency, can you clarify the difference between being automatic and being fluent with computation?
Yes, that's a great question. So what we're looking for, and one of the things that's really difficult with math facts is we don't have a lot in terms of, I work with teams all the time that are looking for that whole timing piece. How many problems should students be able to do in 1 minute, let's say? If you look that up for reading, and you're looking for automaticity or fluency in reading, there's a lot of information about that and a lot of research done on that. But we don't have the same in math. And so what we really emphasize is not so much that students can do math with lightning speed. And what we ask teachers to think about all the time is when we're doing math in our own lives, in our daily lives, it's not about hurry fast, Rachel, how quickly can you calculate this? But it's more I can figure the problem out in a reasonable amount of time. And so what we're looking for is through that timing element, as I was saying when I was introducing that slide, we introduce the timing element once students are fluent with the strategies. Once they have the strategies, then we introduce the timing. And through the timing, through maybe 1 minute, or a more effective way would be for students to time themselves and to try to beat their own time versus setting a random 1 minute and trying to do 100 problems in a minute. So it's less problems and less amount of time, but what we're trying to get students to do is to build on their own automaticity, their own fluency with those problems. So are they getting better at that? And once they get better at it, then we can introduce the pressured timed test, which makes sense as an assessment tool, but not as a teaching tool.
Can I just add to that?
Yes. Please.
In Singapore, we try to distinguish between being automatic and being fluent. So being automatic is when you see 29 times 4, you know straight away what to do. Or if you see something like 7 times 3, you know it as a fact that it is 21. Being fluent, on the other hand, means that I'm able to think of other alternate ways of doing it. So 29 times 4. Other than using the algorithm, a child who is fluent might also say, oh, I could do 30 times 4 and then compensate by subtracting a certain amount. So that's how we distinguish between being automatic and being fluent in our own curriculum here in Singapore.
Thank you so much.
And actually that leads to a question also here in regard to whether or not we'll be covering strategies in the BAR method during the webinar.
Earlier in the presentation, I shared one example on the use of the BAR model. And if you look back at the slides, you might be able to see how we use that. I suppose we are going to see more of this during the conference itself.
And we will, of course, make these slides available to you. Let's do this final slide and then take some more questions from our audience, please.
Absolutely. The final slide here talks about the teacher's role in problem solving. And if you just read through those, one of the things, a few things that I'd like to call your attention to, that second bullet, believing that students have the capacity to problem solve is an essential part of the problem solving process, and just making sure that we hold true to that belief and that we begin from that belief with everything that we do. And that we understand that they have the capacity to problem solve. However, it's up to us as their teachers to provide the structures and provide the opportunities for success so that they're able to believe in their own capacity to problem solve, because that's really the issue. They don't believe that they have the capacity to problem solve. And then that third bullet, we really emphasize not saving students. So when they're engaged in problem solving and we're walking around the room and we're listening in on their conversations, that's really what we're doing. We're using it as a process of collecting formative assessment information on our students and listening into those really critical conversations that they're having that provide a window into their understanding. But what we shouldn't be doing is diving in to help them or provide clues or provide hints. And so we want to make sure that we don't do that when they're problem solving. And again, building their capacity to problem solve. And the final one, becoming a problem solver, doesn't address the students. It's actually about us, the teacher. So through repeated experiences of problem solving, not only are our students becoming better problem solvers, but we're becoming problem solvers, and that increases learning for everybody.
We're now going to take some additional questions from our audience. And in addition, even if you don't have a question, we always value your suggestions for topics that you'd like to see in future webinars. So, Kathy, please proceed with the next question.
Well, in fact, one relates just to the previous slide. Rachel, Tonda asks, what does SAVE mean?
Okay, so SAVE means, and that's a very good question. Thanks for asking that question. I was just coaching a teacher a few weeks ago, and her students were engaged in a problem-solving task, and she was, as we were walking around, she was like, you know, what exactly would constitute saving? Because I'm asking them questions, and so our thinking is if you're providing anything new, any new information that they don't already have, that would constitute saving. So adding anything to their current understanding would be saving them. Maybe giving them a formula when you know, I know that there was a particular group of students, they were trying to find the area of a triangle, and the area of the actual formula they were using was area equals base times height, which was incorrect, and so she really wanted to guide them towards knowing that that was the wrong formula. And so what she did instead of saving them and giving them the formula, she was asking them some probing questions. And through her questioning, trying to get them to think about, now take a look at the shape that you have, and think about the formulas and how we would find the area of a triangle, and then walked away and let them engage in some more conversation. And it took a few attempts and a few different questioning prompts, but through her questions, they were able to eventually come to the idea that their formula was incorrect. So that would be an example of saving.
Excellent. Here's another question. How is the balanced math program tied to Singapore math program? One of our attendees said they are interested in purchasing Math in Focus.
So the 5 easy steps works with any program. So with Singapore Math, it would basically just be a way of organizing the math instruction. So a way of making sure that when, for example, you started a new unit or lesson, that you went through that idea of what are our students, what is the background knowledge or the background math, the previous math learning that would keep our students from being successful on this particular unit of instruction. And then we would design our math review component or our math review practice to support the learning within Math in Focus and within the math program. So again, it is not an additional program. It is not something that you have to purchase program that you have to purchase. It is all teacher practices. So it's all what we do with the materials that we have. So that's why it can work beautifully with any program that you currently have in place.
Here's another question. How do you see iPads and other one-to-one student devices fitting into a math program? Seems there's a strong push to get them into the classroom.
In a Singapore curriculum, we do emphasize the use of concrete materials prior to pictorial representation. So when we use the iPad, it is not really concrete, as in you cannot touch the objects, but it is concrete in some sense that you can move the images around. So we see iPad is somewhere between the concrete and the pictorial representation. So our teachers have been told quite explicitly that the iPads are great, but please provide the children with the concrete experiences when they first learn a new concept. Mm-hmm. And then the iPads can come in to make images that previously couldn't move Now you can manipulate those images. So it's a great resource to have, but it still does not replace the use of manipulatives in the classroom.
And I would agree with that.
And actually, to that point, one question is the quote-unquote Singapore math model, in the Singapore math model, what is the extent of calculator use? At what point?
Officially, the teachers use calculators only in grade 5 and beyond. In other words, it is quite rare to see significant calculator use in grades 1 through 4, or incidentally, kindergarten is not part of our formal education system. So in grades 1 through 4, you would almost never see a calculator in a classroom unless the teacher happened to be doing some exploration with patterns, number patterns. However, from grade 5 onwards, once they have mastered the basic number facts, the use of calculator is now common. In assessment, there is a segment of the assessment, 40% of the score, that comes from a paper, a test that does not allow the use of the calculator. And 60%, which is problem solving, allow them to use the calculator. So grade 5 and above, the children will use calculator.
Excellent. Well, we have the questions are coming in fast and furious, but here's another one. I believe that mathematical reasoning is the essential component of problem solving. What strategies can we use to teach and or promote mathematical reasoning?
In the Singapore mathematics curriculum, a very common strategy we use to develop mathematical reasoning is the teachers asking the question why. So 1 divided by half, 1 divided by 1/2. So why is your answer 2? So the textbook will encourage the students to use a diagram. So the teacher will be asking, in 1, how many halves are there? So through the use of language, our teachers try to help children develop a way to reason whatever computation that they are doing. So another example will be, if I want to do 9 times 6, but I forget what it is, but I remember what is 10 times 6. How can I use 10 times 6, which is easy for me, to compute or to recall 9 times 6? So the connection, the reasoning. So the use of the question why.
I would just also add that if you're in a state, and many of you are, that has multiple choice tests on the exams, and the temptation can be to use those multiple choice tests as the way to prepare students. If you really want to get at mathematical reasoning, don't just drill the multiple choice test to find the right answer. Require students to explain why one of the wrong answers is wrong. And I found it particularly useful if they will make that explanation in writing. That way, even if they get the wrong answer, you as a teacher get much more valuable information by knowing what they don't know, that is, they didn't get the right answer, but also knowing what they do know if they can explain why a wrong answer is wrong. That gives you insight into their reasoning.
You might be interested to know that in Singapore, we do not use multiple choice in our classrooms. So our textbooks do not contain multiple choice items, hence the teachers do not use them.
And I was just going to reinforce both of those points. With 5 Easy Steps, mathematical reasoning is really reinforced through those probing questions, just as Dr. Ban Har was saying, asking students to explain their thinking, and then the values of nonfiction writing. We all know the importance of writing in all content areas. However, particularly when we're talking about math, when students write in math, it really provides for us a window, but it provides for students an opportunity to show us their mathematical reasoning, to show us their thinking.
We're down to only a few minutes left, Kathy. Are there a couple of more questions that we can take?
There are. Here's one. If a new student enters schools mid-year, is there an assessment measurement that helps identify the unit components that are already mastered or needed?
Would that be specifically for Math in Focus? I know as far as 5 Easy Steps to a Balanced Math program, there wouldn't be a specific assessment that we would have, but that is something that we encourage through that idea of common formative assessments. So for teachers to work collaboratively with their PLC, with their data team, to create some sort of an assessment that would give us that information, that starting information, right off at the beginning of the unit or beginning of the school year, wherever we would want to do it, so that we would know where students' strengths and weaknesses lie.
In Singapore, students don't move halfway through the year because Singapore is a very small country. There's really no need to do that at all. But in the instance when a child comes in from a different system halfway through the school year, our schools will design a test on their own to assess where the child is. So we do have a test, but for American teachers who are using Math in Focus, that program has a prepared assessment that you can use to find out where the child is.
And actually, someone just asked in regard to assessments, how often are assessments given with the Singapore approach?
In Singapore, we do achievement tests, as in standardized tests, a national test, only once at the end of the 6th grade. In the schools, it is common for the schools to do formal achievement testing twice a year, middle of the school year and end of the school year, with the exception of the first 2 grades. So in grade 1, it's kind of illegal, I'm joking, but it's kind of not encouraged, and schools do not do it. In 2nd grade, they probably do not do it until the end of the year. So with the exception of the first 2 grades, 3rd grade and beyond is common to see twice a year where the school will give the students some kind of a test. And national test, we only have it at the end of grade 6 for the elementary school.
And here is one more question. When we are talking about effective problem solving in computation, where does paper and pencil fit in? Research is still leaning in that direction, but if teachers are pushed away from it, are there any acceptable substitutes?
In Singapore, we continue to use paper and pencil because we have not yet reached that level where we are able to assess students using other available technology. So we continue to do paper and pencil, where we expect the students to articulate their reasoning, communicate their way of solving a problem. It's on paper.
Yes, and also through the 5 easy steps, a big part of each of the components is really students using paper and pencil to show us their thinking. To when they're doing problem solving, we have them create something called a data sheet where they record all of their thinking, and we actually ask them to not erase anything. So if you start down a possible solution and you find midway that you are wrong, you just leave it there, cross it out, or do whatever, and then continue somewhere else. And the reason that we do that and emphasize that so much is, again, we want to see their thinking. We want to be able to really diagnose where their misunderstandings are taking place.
Well, I hate to interrupt such a wonderfully fruitful conversation, but I want to thank particularly our guest, Dr. Yeap Ban Har, Rachel Syrja, and all of our very large audience today from around the world. Thanks also for letting us know some additional ideas that you have for future webinars that you'd like to have. We'll do our very best to continue to serve your needs, and we certainly hope that we'll see you this summer in Colorado. To my colleagues, thank you very much, and have a great rest of the day.
Thank you.
Thank you very much.